All right, people, it's time for the last section in college algebra. Section 10.1, we'll be looking at solving systems of linear equations using matrices. We already solved systems of linear equations back in 9.1 and 9.2. Two equations with two unknowns and three equations with three unknowns. Now we're going to use a little something called a matrix to help make our process of the solving more efficient. Okay, so what is a matrix, first of all? And it says the data in table 10-1 represents the BMI for people of selected heights and weights. So what we can do is we can kind of extrapolate the most important information from this chart and put it in what we call a matrix. And so you'll see 21.9. The first entry is the first column, first row, 21.9, 25.1, 28.2, so forth. 23.7, 23.7. So you just put those numbers in what we call a rectangular array of numbers, and that is what we refer to as a matrix. Okay? Now, it says a matrix can be used to represent a variety of things, such as a system of linear equations when written in standard form. If it's not already organized where every thing's on one side as far as the variable goes and then the number on the other side, then you need to move it around to where it is in the standard form on our system of equations. And then we can write the coefficients of the x values in the first column, 3, 1, 2. In the second column are the coefficients of the y values, 2, understood to be -1, and understood to be +1. The coefficients of the z, this would be 0z. Okay, I didn't change anything there. So the coefficients of z would go in the third column. That is the 0, 3, 1. And then just the constant numbers, 5, 1, 4, would go in this last column. Now, we call this an augmented matrix. So what we refer to as the augmented matrix is with this vertical bar in here. With this vertical bar in here, that separates the coefficients of the variables along with the constants. The constants go in after the vertical bar. So if you want to pause and study that a little bit, see how all that works, that might be a good idea. If not, then let's push on. And we're going to actually work on writing the augmented matrix for this system of equations. Now, this one is not organized like we need it to be. Okay. First of all, on the top equation, I'm going to run the 2 through. So I'll have 2y minus 2x equals 4 minus 8x. And so for my top equation, when I add 8x to both sides to move this around into, I know it's kind of getting kind of crazy there, into standard form, this one organized, let's write the x terms first. So this will be a 6x minus 2x, 8x minus 2x is 6x. Now let's write the plus 2y term equals 4. And then on the second equation, all we need to do is add x to both sides to get it in standard form. So when we add x to both sides, we'll have x plus 5y equals 6. So now the augmented matrix for this system, okay, is going to be a 6 here, then a positive 2, then let's write our vertical bar here, and then the 4. And then in the bottom equation, we've got an understood lead coefficient for the x of 1, and then we've got a 5 and a 6. So here is what we refer to as the augmented matrix for the system that realize has two equations with two unknowns, x and y, and see what corresponds with what when we actually write that, system out. You have to keep in mind what corresponds there. Okay? Now on number 18, part B, what we're going to do is write out the linear equations that correspond with this given augmented matrix. Now down the first column, don't forget that these are all the coefficients of the x's. In the second column, those are the coefficients of the y's, and in the third column, those are the coefficients of the z's. Okay? And so when we write this out, I'm going to write everything, okay? I'm going to have 1x for the first equation plus 1y minus 2z equals the first constant, -4, okay? And then we've got 0x plus 1y plus 3z equals 8. And then for the last row in the matrix, we would have 0x plus 0y plus z equals 2. Now, that's fine how you have it, but really we want to kind of clean this up because the top equation for our system is just simply going to be x plus y minus 2z equals a -4. The middle equation will just be, and we usually kind of scooch over a little bit and just say y plus 3z equals 8. And the last equation, most simplified, is just z equals 2. Okay? Now, you're going to want to probably work with it more. We're going to talk about some good ways to work with it in this augmented matrix form to solve the system of equations. But look at what we would have here. You already know what z is. Z is equal to 2. Well, if you know that z is equal to 2, can we not pretty easily kind of do what we call back substitution and find what y is? Well, if z is equal to 2, y would end up being 8 minus 6. It would also be 2. And so if y is 2, then you could also find what x is. Let's see, it'd be -4, and then plus 4, and then minus 2. I'm not exactly sure I did that right, but I think x is equal to -2. That's where we're heading in this section. But we are going to use this augmented matrix to get us there so that we don't have to write all those x's and y's and z's and equal signs and all that. We can just work with the most important part of the system, and that's all these coefficients and constants within the system. Let's see how all that works.